Hello everyone and welcome back again. This is Omar Al-Tuwaini, and in this video I will introduce to you the algorithm of CART under the package of RPART for decision tree using GIS data in our environment. With this CART for classification and regression tree, one of the best example for using decision tree. So actually it gives you a wonderful tree shape and the importance of every predictor as well as further statistical tests. So if you plan for decision tree, the best example of to start with CART, it will fulfill your needs. So here a short description about all the functions inside the CART, and which we will talk about that during the effective steps. So first of all, if you are with us from the first video of along this course, so you will learn how to prepare the data. Otherwise, here also I put a summary of how to prepare the data. So first of all, you need to create a directory and then set your working directory, and then you create also a library. Then you can save all your packages inside, then you can refer it wherever you are offline or you want to carry it by pen drive. So now I need to install all the libraries again. So just follow the steps, set your working directory here, and then set your library. We have a few parameters we already developed based on ArcGIS, so they are all TIFF maps, and we save them in my data folder. Now we need to read them, and then after we read them, we need to resample all the data. Okay, so whatever we have a data here, we need to resample them in the same extent and pixel size of all the other parameters. So either you can do this in ArcGIS or you can do it also here. So in this case, after we resample the data, we need to save them in one folder. We call it resample. Okay, so the data here, we read the data first: elevation and DVI, slope, curvature, and training data. We can just read them, and then we save and we try to resample the one that it has a different extent by reading every parameter. So str, for example, and you are putting the slope. Okay, so check the information of the slope here, or take the summary of the slope, and also for the rest of the parameters. Okay, so you can understand here the information for every parameter and or the pixel size and whatever. So you try to follow this style for all the factors, following the same extent and the pixel size. After you resample them following one parameter, like for example elevation, save them in one folder, then start to read the data. If you have any problem about this, please refer to our previous data about how to use logistic regression in the same channel of Al-Tuwaini channel. We describe and we talk about every step in details. Here, if we list the files that already we saved them in resample data, we will read and we will try to stack all of those parameters inside one folder. Okay, and we put them inside one file. Okay, so in stack multiple raster files, so rasters we have inside this folder, we will list them, and then we start to stack all of them all together. So now you can check your stack names and the heading the data. So then the data you can see here, it has some missing values. Try to remove this missing values using the code here. just copy to a new folder, a new parameter, and after that omit the no data, put it in one data frame, check the heading. Now we have a new file without missing data. Training data, you can see here we have a training. We want to change the column name into training data instead of training. You can follow this code, it will change the header of the column. Okay, I'll change it to data frame. So now, following another technique of creating testing data, which also we described this earlier. Now you have a testing data.csv, so we will read the data from CSV file instead of reading them from TIFF files as we did here for training. So for testing, it's simple as we are just reading. We read the CSV file. After we read it, we check the data, and then if we have a different column names, we try to make the column names has the same header. If you can do it in Excel, or you can do it here by using those codes to change the header. So we'll run all of them together. Even if you have a capital letter and small letter, you make sure that you have the same header. So now after we change the one that it has the differences, we check the dimension. Here we have 50 observation for training, of 150 for training, 50 for testing, and 150 for training, with 5 parameters. And here we can see that our training data is numeric, so make sure that when you face any problem with the code, we say that data should be factor, you should use as dot factor and you put the training data. Otherwise, if it's numeric acceptable, you just move on with the numeric. So now we need to install the package of rpart to run the cart model. So I already installed it, so I will read it directly. So library rpart. So now the function of let's call it, just put any name, so I call it DTM here. This is for cart model, decision tree model. rpart, this is our function. Training points, this is your training column. Training data, the entire data, use the entire data as we talk about this point. So if you want to list data one by one, for example, you want to say slope, elevation, better to use the what RStudio proposing to you, then you won't have any problem with the spelling. So for example, I put here a capital letter, it should be a small letter. Okay, so here you have a curvature. So try to just to take the parameters that proposed by the software, NDVI. Yeah. So if you want to run this one, for example, you said I don't want to use the NDVI, I need to use the NDVI. Okay, so now you can just define the data. This is sub data, so this is our training column or training variable. Within the other independent factors, list them here, and then the method is classification. Because we have categorical data, and then this is extra control, so you need just to copy this statement. No need to change anything. Minimum split 1. This parameter here you can change them to get a better tree. Here what's Okay, so now we run the model here using all the independent variables inside the training dataset. Reading, now the model is ready. Now let's check the model by plotting the model. You can see also here we have a tree without text. By adding text greater equal 0, now you can see all the text come with us, but as you see here, it's not professional drawing. So we will try to modify this and to plot it in a better way using different functions. But let's try to read the summary of the model what we have. So you just type the model DTM. Yeah. So now you have your tree, but it's written as a text. So you can get the information here in the root. The first node started 150 and you have 75 of 0, 75 of 1. It started from the slope more than 35 and it has the details, so it's a little bit confused here to read it from a text, so it's better to plot it as a tree. So we'll show you how to plot it and avoid the headache of the text here. So it's better that we can follow a different package of plotting here, professional plot, using rplot.plot. This is a different package here. So library, and then we plot it here. So now we can see the plot here in a different way, look more professional, because the plot it's huge, so you can't see the text clearly here. Then you can take the also summary actually, and in summary it's a quite rich summary. On the summary, if you come to the first line, it will show you the variable importance, which of the variables that has more importance. So always you can see the slope has the highest accuracy or highest importance level value compared to the others. Also it will show you some details about the cross validation, which we will use it in the pruning stage. So if we come back now, we want to do some pruning here to enhance the if we want to enhance our result. So come to the model again. After we plotted, actually we want to display the CP table. Here in the description I put the information about all of these parameters. So the print CP, it's the display the cost complexity factor table, okay, which is related to the error and cross validation error. So the CP, the cost complexity factor here, it will tell you where we can or which value of CP we can get, then we will have the smallest error. So you can see here within CP of 0.01 we have a less error. Let's see how to apply this. Yes, now check the CP for this DTM, so it will give us again the same results related to the CP here. Okay, and then we will plot the CP. We want to see based on plot. You can plot this one to make it more comprehensive. You can see now the plot here. This is the error and this is the CP value. So CP value starts from 0.098. It has the lowest error value, so you can consider this as a CP or the adjacent one. All of here, this is starting from the root and then continue with the growth. When you reach here, after that you start to have error or the error will increase again. So it's better to stop the tree in this point of CP. And here, if we take the approximate R square and relative error, also we can get. So here it will show you, if we consider as a number of split, we can take the third split here. It will also give us the smallest relative error. So as you like, either you can follow the CP, or you can refer to the relative error and you can see the log here. Okay, so it's quite informative. Actually, it has a lot of results here. You can use them in your article for comprehensive discussion. So now we will come and we will try to so now, after we saw the CP values, and then we want to plot the trees. I said we have a professional plot here. Either you can use the R plot, or you can use the different plot also function here, which is also is considered to be comprehensive as well. So you can follow also this function to print the result. If we come here, we'll start it from the slope. So how to read this one? For the first point, you have a value of 75 number observation for 0, 75 for 1. So let's start to see the division here. In this leaf, you have 37 and 3. What is referred to? Actually, you can see here, this is one referred to 0 and one referred to 1. One referred to a number of non-landslide and one referred to slides. So if the number of non-landslide is higher, you can see it's coming here. So this is a 37 zeros compared to 3 landslides. So you can see number zeros is higher, so they will put 0 here. If you have, for example, after that you will have 75, so now you have 38 compared to 72 of 0. So 38, because already we took 37 here for 0, so what left for us 38 out of 75, and still we didn't use the 1. You can see here also 75 is still for 1. After that we try to classify also this value into further. So whenever you see the number, you see 64, so it's higher, so that's means it's for 1, left side for 0, until you finish all your notes and it's come to classify all of them. You can notice here that we have 1 to 5 values of 1 and 1 value of 0. So it's come here, this one for 0 and 0 for 1, so it's all of 5. It's come here, 5 to 1. So this is the terminal notes. So in this, actually this tree of cart is quite comprehensive, and you can discuss all of the results here step by step. Now we'll come and check the prediction, actually using the testing data. So here the prediction, we'll check the prediction almost 50%. You can see for 0 and for 1, if you sum up 4 plus 21, you have 25 out of 50. Okay, so that's mean the accuracy is 50%. So you can check here, yes, this is your accuracy 50 for testing. Again, it's better than the previous methods that we discussed in the 3 or C5, almost it's a 50% here, almost near to the C5. Now after this step we try to do the pruning. Let's see how we can enhance our result. So pruning for fit for the model, prune for the DTM, our model, and use the CP. CP, if you remember the value we give here. Okay, so we try to choose between 0.09 and between 0.03. We choose 0.04 almost here to represent our lowest relative error. So we will prune based on the complexity factor here. Okay, now this is the as if it's the new tree for us. P-fit, it is the tree after pruning. Now let's plot our tree. Definitely it will be smaller than the original tree. You see, if we trim here in earlier stage, you see it's become a very small tree. So it's better if you try to trim, you just give some comprehensive value. So if we just, for example, trim in 8, it will be bigger. Sorry, we'll copy this value. Yeah, if you trim in 0.1, you see the tree is look bigger now. Okay, so you can decide now if you go further on the x-axis, increase your CP value, it will yield a bigger tree. Okay, if you come with the low value of CP or high value of CP, it will be a small tree with higher accuracy. So you can optimize this or trade off based on your needs. And this will also, it will tell you the number of splits. So you can see if we continue on x-axis, we will have more number of splits. Anyway, so now if we make it again, let's see. Okay, this is the size. I just to get it better. I move to 2. Yeah, you can see now the tree is almost medium scale. In this stage we reach to the end. So this is your prune classification data using the testing point. Thank you very much.